G'day everyone, Brian Odian with another episode of VikingCloud CyberIntel. Back in 1999, like many other people back then, I was working through nights updating systems when everyone went home to ensure the Y2K problem wouldn't be an issue on the 1st of January 2000. Now, for those who missed the event, feel free to look it up. But needless to say, there would have been large ramifications had the issues not been resolved in some sectors. Because remediation was so successful and everyone had enough notice of the issue, the impact was so minimal, people began to wonder if it was an issue in the first place. I have to say, that was a kick in the guts for many of us who worked through nights to keep the issue at bay. So what is the next challenge that will impact the world, requiring global rectification if we're going to weather it? In the words of NIST, if large-scale quantum computers are ever built, they will be able to break many of the public key cryptosystems currently in use. This would seriously compromise the confidentiality and integrity of digital communications on the internet and elsewhere. Michelle Mosca, a co-founder and deputy director for the Institute of Quantum Computing at the University of Waterloo, said, "I have estimated there's a 1 in 7 chance that some of the fundamental public key cryptography tools upon which we rely today will be broken by 2026 and a 50% chance by 2031. Although quantum attacks are not happening yet, critical decisions need to be taken today in order to respond to these threats in the future. And organizations are already being differentiated by how well they can articulate their readiness. NIST have been working on post-quantum cryptography since 2016. And they've selected several algorithms to move forward with. They state the goal of post-quantum cryptography is to develop cryptographic systems that secure against both quantum and classical computers and can interoperate with existing communication protocols and networks. So when do we need to get started by to avoid the next big challenge for systems across the world? NIST said, historically, it takes almost 2 decades to deploy modern public key cryptography infrastructure. Therefore, regardless of whether we can estimate the exact time of arrival of the quantum computing era, we must begin now to prepare our information systems to be able to resist quantum computing. Even the FIDO Alliance said in a paper entitled Addressing FIDO Alliance's Technologies in a Post-Quantum World, migration takes time, and security agencies are requesting to plan for protection now. A post-quantum strategy for migration is necessary. Think about every system that uses some sort of cryptography and having to change all of that out. The FIDO Alliance, NIST, and many others started looking at this a while back, recognizing that change will take time and time is running out. The Y2K fixes were relatively easy compared to what's coming in the implementation of post-quantum cryptography globally. It will be a massive endeavor compared to fixing Y2K. So start looking at it now because, as NIST said, while in the past it was less clear that large quantum computers are a physical possibility, many scientists now believe it to be merely a significant engineering challenge. Until next time, stay vigilant, stay informed, and stay secure.